My name is Nini Ramazlin binti Muhammad Som. My metric number is AN220006. I will present part introduction. So, automation plays an important role in addressing everyday challenges in industrial and warehouse operations. A recurring issue in these settings is the presence of misplaced metal objects, such as screws or bolts, which can disrupt production processes, damage machinery, and also endanger workers. Relying on manual method to detect and collect these objects often lead to inefficiencies, increased downtime, and also safety risks. As industry move toward adopting smarter technologies, the need for automated solutions to tackle such challenges has become increasingly apparent. By integrating robotics with embedded systems, this project exemplifies the potential for smart automation to enhance industrial workflows. For problem statement, in warehouses and industrial environments, misplaced metal objects like screws, bolts, and tools create significant safety risks, damage machinery, and disrupt workflows that leading to costly repairs, downtime, and also decreased productivity. Traditional detection methods, primarily manual inspections, are time-consuming and also prone to human error. It also lacks real-time monitoring and often resulting in undetected hazards. To address this, the proposed solution is an autonomous line-following mobile robot with metal detection capabilities designed to navigate predefined paths and identify metallic debris in real time. This system would reduce the need for manual labor, enhance detection accuracy, improve safety, and also optimize operational efficiency that ultimately creating a safer and more productive work environment. We have three objectives. The first one is to design and develop a prototype of a line-following mobile robot that equipped with metal detection capabilities. The second one is to enable the robot to autonomously navigate a predefined path and also accurately detect, count, and display the number of detected metal objects. The last one is to integrate embedded system and utilize the CBOS platform for effective real-time task management.
Next is project description. This project involved developing an autonomous line-following mobile robot with metal detection capabilities to address the issues of misplaced metal objects in warehouse and industrial environment. The robot follows the predefined path using specialized sensor and detect metallic debris like screws, nuts, and bolts using a metal detector sensor. An Arduino or Maker Uno microcontroller coordinates the system with an OLED display showing real-time updates, including the robot's name, group details, and detected item count. The robot operates using the CBIOS platform with three core tasks. First is displaying project info, second following the line, and lastly is detecting metallic object. This solution aims to reduce human effort, enhance safety, and optimize industrial workflow by providing a scalable and efficient method for detecting and managing metal debris.
The circuit is designed to control a line-following robot, enabling it to follow a path and avoid obstacles. The Arduino Uno microcontroller acts as a blueprint of the system, processing signal from sensors and controlling the motor. The robot is equipped with IR tracker sensors, which detect the black line on the ground, and proximity sensor to identify obstacles. The motor driver L298N receives command from the Arduino and control the 2 DC motor, enabling the robot to move forward, turn, or stop. The OLED display provides system updates or sensor data for monitoring. Power is supplied by batteries, ensuring smooth operation of all components. The robot works by detecting the line with the IR sensor and sending the data to the Arduino, which decides the direction of movement. If an obstacle is detected, the proximity sensor signals the Arduino to stop or redirect the robot. This simple yet efficient system enables autonomous navigation along a defined path.
Keras hati
Next is list of components. For this project robot have 7 items that we using. Firstly, 2-wheel smart robot car. Second is IR line tracker module. Third, breadboard mini. Fourth is OLED LCD. Five is Maker Uno. Six is proximity meter detector. And lastly is Maker drive.
For the programming flowchart, the flowchart starts with the start, and then it includes the library, which is the chret.h, the wire.h, the Cytron motor driver.h, the SSD1306 ASCII.h, the SSD1306 ASCII.wire.h, and then it go to define the RST pin, which is the negative one, and then it configure the motor drivers, configure the sensor pins, and then it uh, came with an output, which is it print hello, I am Mekamoto, and then it print another line, which is the I'm from group 7, and then it delay for 5000 millisecond, and it start to multitask, which is the thread 1 and thread 2. So for the thread 1, it define the pin and note, which is the melody note, and it initialize the start melody, the start note duration, stop melody, and stop note duration. And then it start to read the value of the IR sensor for the IR left and IR right. And then it go to the if else selection, which is the first one. If the digital read, which is the IR left, is high and the IR right is high, the robot will go forward, and on the serial print it will print forward. And next one, if the selection choose no, it go to the next selection, which is if the IR left is low and the IR right is high, will go to the robot turn right, and the serial print will print right. And if the digital IR left is high and IR right is low, the robot will turn left and the serial print will print left. And the last one, if both is low, the robot will stop and the play stop melody will start playing, and the serial print will print stop, and the system will sleep for uh, 25 millisecond, and it will repeat to read the IR value. So for the thread 2, it initialize the pin, which is the pin 2 on the Arduino Uno, and it initialize the count, which is 0, and then it initialize the sensor value as the digital read pin. Then it will read the sensor value. If the sensor value is low, if yes, it will go to sleep and it will repeat reading again, and if no, the counter will increment, and the OLED will clear, and the OLED will print number of metal, and the next one, the OLED will print detected equal to, and it will print the number of count.
Assalamualaikum. My name is Muhammad Izzat Firdaus bin Roslan. Uh, I will explain the RMS analysis. So, we perform this analysis to determine if the deadlines can still be met even if the utilization exceeds the limit. Firstly, task 1 has the highest priority. As you can see, the completion time C1 equal to 36 milliseconds, and the deadline T1 equal to 36 milliseconds. So it meets, so the deadline is 36 below 36, like that. So task 2, we take the contribution from the task 1, which means 128 milliseconds. We divide by 36 times 36 equal to 144 milliseconds. So the C2 of the task 2 is 8 milliseconds. So we just plus the task 1 plus C2 equal to 152 milliseconds. So we determine the deadline T2 equal to 128 milliseconds. So it missed the deadline, which is 152 more than 128 milliseconds. Next, the task 4. Task 4, we take the contribution from the task 1 and task 2. Then we add its own execution C4. We just plus the 144 plus 8 and plus 8 millisecond equal to 160 millisecond. So we detect and we analyze it missed the deadline, which is the 160 millisecond more than 128 millisecond. And lastly, the task 3. So the task 3, we just do the same thing. We take the contribution from the task 1, task 2, and task 4, and we just add with its own execution, which means 8 millisecond. So equal to 168 millisecond. So we analyze it missed the deadline 168 more than 160 more than 136 millisecond. So in the conclusion, we detect the CPU utilization exceeds the schedulability limit, which is 1.1836 more than 0.756. And besides, we analyze the deadline analysis for task 2, task 3, and task 4. They miss their deadline under RMS. So we analyze and we conclude the task set is not schedulable under RMS, and consider re- the reducing execution times, increasing the period. That's all.
Next is results and discussion. Firstly is line following robot performance, which is have 4 points. First is when the robot is turned on, the IR sensor will activate, and if both of the IR sensor is high, both of the motor will activate. Second is if the IR sensor left is low and the right is high, the robot will turn right. If the IR sensor for left is high and right is low, the robot will turn left. Lastly is if both IR sensor is low, both of the motor will turn off. Second is metal detection performance. First is the metal sensor detects metal and it will display the number of metal detected on the OLED LCD. Second, when the metal detected, it counts the exact number of the metal. Third is OLED display. The OLED display the message on the OLED, which is hello, I'm Mekamato, which is our group name, and I'm from group 7. Second is the OLED display no number of metal detector. Lastly is the OLED function very well.